Welcome to Session 7, Percent Change, Markup, Margin, and Interest. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to identify the correct percent base, to reverse successive changes, and to separate markup from margin. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Successive percent changes act on updated amounts. Use this visual structure. Original x factor 1, x factor 2 equals final. Read every symbol and label before calculating. The first goal is to identify the correct percent base. Connect it to the second goal. Reverse successive changes. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Write the base in words. State the target and preserve its units or conditions. Step 2. Convert each change to a multiplier. Use a separate line so signs, factors, and labels remain visible. Step 3. Multiply forward or divide backward. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Check using the original context. Verification is part of the solution because it tests the answer from another direction. Signal 1 is increase by R%. Respond by remembering. Multiply by 1 plus R. Name the response before calculating. Signal 2 is reverse and increase. In that case, divide by its growth factor. The form tells you which tool fits. Signal 3 is profit margin. Remember, divide profit by selling price. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here's a challenge. What is 5,000 worth after 1 year at 4% compounded semi-annually? Restate what is requested before touching the choices. The first move is, write the base in words. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. Two 2% periods give 5,000 1.02, squared equals 5,202. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Multiply forward or divide backward. The explanation supports one option without relying on its position. The mathematical conclusion is 5,202. State it with any required units, interval notation, or restrictions. The final answer is 5,202. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Work forward from the recovered original amount. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Why are successive percent changes represented by multiplication? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. The focused hint. The base after the first change becomes the input to the next. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is, each change acts on the updated amount. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to identify the correct percent base. Combine that with the discipline to reverse successive changes. Finish by remembering to separate markup from margin. A result becomes dependable only when the method and verification are both clear. Reflection. Which denominator did the wording require? Cost, selling price, or original amount? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.